welcome to the JPS monthly product briefing. I am Carol Hollingsworth. I'm with Iggy Brigado, the JPS senior sales engineer. Iggy will provide you with today's product presentation. We truly appreciate your being with us today. We're confident that you will learn more applications for JPS products and how to expand the uses for our products. In today's webcast, we will focus on controllerless integration of the JPS MCC Multi Channel Console with push-to-talk over cellular services provided by ESChat, Tango Tango, JPS VIA, Motorola Kodiak, AT&T Enhanced PTT, Verizon PTT, and Zello PTT. The MCC Multi Channel Console shines in large distributed wide area systems that are supported by either a Z series controller or an ACU-Z1 Modular Gateway. MCC consoles can also be integrated with push-to-talk over cellular systems without the need for a controller element. If you want to add a hardware console to your push-to-talk over cellular talk group without any additional recurring cost, you'll learn how to do that today. We truly appreciate your being with us today. Now let's get to today's product presentation with Iggy Brigado. Iggy?
Hi, Carol, appreciate the introduction there. But I'd like to welcome everybody to the JPS Interoperability Solutions monthly products briefing webcast. I'm Iggy Brigado, senior sales engineer. And as you know, we always have here with Carol Hollingsworth, our VP of sales. And in this month's webcast, we're going to discuss simple controllerless MCC console integration with a push-to-talk over cellular talk group. And we had a couple of webcasts that featured the JPS MCC4 and the MCC1 Multi Channel Console integrated into wide area systems. And this is really where the MCC Multi Channel Console really shines. Those large wide area systems that are managed by a system controller like the C series controller or the ACU-Z1 gateway. And so we'll see how we can integrate the MCC console with your push-to-talk over cellular services without a controller. And currently, these are the push-to-talk over cellular service providers that we directly support with all of our gateways. And the RSP-Z2 dual channel gateway and the ACU-Z1 modular gateway will also support all these services. And these Z series gateways are really your best push-to-talk over cellular gateway options, and you'll see why. And hopefully you've learned that from our previous webcasts as well. But our legacy gateways, such as the ACU-2000, the ACU-5000, the ACU-T, and the ACU-M, will support all of these push-to-talk over cellular solutions, with the exception of the Kodiak services. And this is due to the TLS encryption requirements of the Kodiak-based services, such as the AT&T Enhanced PTT and Verizon PTT Plus. But the good news is that all Kodiak services are fully supported by any of our Z-Series gateways, like, again, the RSP-Z2 dual channel gateway and the ACU-Z1 modular gateway. And as you know, the goal of push-to-talk over cellular applications are to allow smart device users to participate in duplex LMR communications. And a gateway, just like the JPS NXU-2B, the single channel network extension unit that you see on the left, is an important part of the integration of LAN mobile radio talk groups or channels with a digital push-to-talk over cellular environment. So the NXU-2A and the new NXU-2B have been our most popular radio gateways used for push-to-talk over cellular applications. So this is a classic illustration of how push-to-talk over cellular services creates the bond between LAN mobile radio talk groups with the LTE or Wi-Fi based smart devices and their applications. So many of these providers also provide a dispatch application that can be supported by a PC. And these platforms allow a dispatcher to conduct person-to-person, group, or talk group voice communications, as well as messaging. And many of these applications have mapping and location capabilities. So these push-to-talk over cellular dispatch applications are really very feature-rich, and you can never go wrong with those types of applications. Alternatively, the JPS MCC Multi Channel Console is a viable hardware-based console alternative to the PC-based console solution. So the biggest advantage of a hardware-based console is that it does not require a PC. However, you'll naturally be giving up a lot of those nice PC-based features that these push-to-talk over cellular providers provide, for the sake of simplicity. And so with that in mind, it's really a great solution when you only need to add a desktop console to one or two of your push to talk over cellular talk groups. And so this is just one example that uses an NXU2B network extension unit in this example. So there are certainly lots more options like the RSPZ2, the ACU-2000, the ACU-Z1, the ACU-M, but let's look at how the NXU integrates into the solution. So we'll talk about the other Z products as well. So first, let's look at some of the different network transport protocols that we need to deal with in this particular example with the NXU. Like we mentioned earlier, the single channel NXU2B is really our most popular push to talk over cellular gateway that supports these applications. So its primary network protocol is the standard JPS protocol. And this protocol has been around for a little over 20 years, and it continues to be a very reliable low bandwidth protocol. Conversely, the MCC console uses the JPS bridge channel protocol, which is not directly compatible with the standard JPS protocol. And the reason we implement two different protocols for transport is that the bridge protocol is more capable in terms of handling data as well as control. So although the JPS bridge protocol is our newest protocol, the standard JPS protocol that the NXU2B implements will always be a standard protocol in all of our new products into the future. And if you attended one of our previous webcasts, that was a couple of months ago, we discussed the importance of standard JPS ROIP as being our method that allows our legacy gateways to be compatible with our latest Z-based products, especially when in the presence of a controller. And so it's all about being fully backwards compatible. That's why we allow the JPS ROIP and the JPS bridge channels to intermingle in the presence of a controller. Again, it's all about backwards compatibility. But really, in reality, in this particular example, we do have a protocol mismatch with the NXU2B and the MCC console. The MCC console only speaks bridge channel protocol, not JPS ROIP protocol. So hence, again, we have a transport protocol mismatch. And on top of that, both JPS protocols implement client-server association model, which means that only two devices can link at one time. We need to include the push to talk over cellular services. The protocols and the signaling used by these push to talk over cellular services may be completely different than those used by JPS devices. So on the digital side, there can be protocol incompatibilities and discrepancies. In a simple ROIP deployment, devices associate to each other, again, using the simple client-server association model. And because these protocols are peer-to-peer, it's difficult to add a third endpoint, like in this example at MCC4 that we see here. We need the NXU2B gateway, the MCC console, and the push-to-talk over cellular services to collaborate and share communications. And each implements a different transport protocol as well as signaling. So a good analogy that I like to use are two tin cans in a string. You can't have three tin cans in a string. It just doesn't work. So when dealing with multiple protocols and multiple devices that need to establish these complex and simultaneous ROIP links with each other, we often incorporate a Z-series controller. We can have a control element in the ACU-Z1 gateway as well. And again, we've had several webcasts that have highlighted the controller. And one of the more important controller attributes is that it can handle both JPS standard ROIP and JPS bridge protocols at the same time. So the controller is really right at home with all these disparate protocols. And it also allows peer-to-peer links to be established, but also allows multiple links to be shared, creating sort of this multicast architecture without the network having to be able to support multicast traffic. And interestingly enough, the controller can support up to 80 individual communication resources. It also provides a really nice browser-based user interface for management and configuration. So it's not a problem linking two disparate protocols between the radio gateway and the MCC console when the Z controller is added into that mix. And if you incorporate the proper radio gateway, we can easily associate these disparate protocols, which includes your push-to-talk over cellular service of choice. But for a very simple single push-to-talk over cellular talk group and a hardware-based console solution, the addition of the Z series controller might be considered an overkill in terms of cost and capabilities. And this is the Z series controller's wheelhouse: large, wide area distributed systems with lots of different protocols. So in reality, the Z series controller is not a practical solution for a simple single talk group requirement. So how do we deal with these different protocols without the presence of a controller? So in this situation, we're going to look at the RSPZ2 dual channel gateway instead. You've heard me say this many times before. Don't let this low capacity 2 channel gateway fool you. This is really one of our most versatile gateways in our catalog. It's pretty astounding. So the 2 channels can function independently. Again, this is a dual channel gateway, and they do not necessarily need to support land mobile radios. They can also support several digital protocols like JPS standard ROIP, SIP, RTP, several push talk over cellular services. And additionally, there are 2 independent backhaul interfaces that can support JPS standard ROIP as well as JPS bridge channels, standard-based protocols such as SIP, RTP, and again, several more push-to-talk over cellular services. So with just a little bit of imagination, you can really easily mix and match any of these protocols over the 4 RSPZ2 interfaces. And if my math is correct, I did this earlier, you can have almost 1,000 different interface combinations with this simple 2 channel gateway. And as you can expect more digital interfaces to come in the future, that number will certainly increase. So stay in touch with us because there's going to be some interesting things coming about, hopefully in the next few months, regarding our interfaces. So here's an example of a simple localized cross connection, pretty common for supporting push talk over cellular. So channel 1 is supporting a donor radio, while channel 2 is supporting the push talk over cellular services, which is a specific LTE talk group. So in this example, we've got the JPS VIA push talk over cellular talk group on channel 2. It can easily be an SLA ESChat based service, any Kodiak based service like AT&T Enhanced PTT or Verizon PTT Plus, or even a Zello PTT service. We can expand the push to talk over cellular talk group into a wide area system using a digital backhaul that we have listed here on the right. In this example, we're able to share the LMR and push to talk over cellular talk group, that conversation, with other communication resources in a large wide area system. So in this case, we would be incorporating a JPS bridge channel that you see at the bottom, and this would be maybe controlled by a Z series controller or an ACU-Z1 within that environment. Again, mix and match these protocols, and you can only imagine the different number of combinations you can establish. And probably the most common push-to-talk over cellular configuration is the independent pass-through, where 2 donor radios can be assigned to 2 different push-to-talk over cellular services. This example shows different JPS VIA push-to-talk channels, but you can even have a completely different push-to-talk over cellular service on the other channel. So it's really all about flexibility in the RSPZ2. So with all that information, let's create a simple integration of a push-to-talk of a cellular talk group with an MCC console. Again, this example will be using a single channel console, which is the MCC1. We can associate our donor radio to channel 1 interface of the RSPZ2. And remember, these are 100% protocol agnostic interfaces. Channel 2 can be digitally assigned to the push talk over cellular services of your choice. And one thing to keep in mind, particularly if you are a Kodiak or an AT&T Enhanced PTT or Verizon PTT Plus user, these protocols are not supported by the front side interface of the RSPZ2. And this is primarily due to agreements with Motorola Kodiak, but in a few months, we should see some sort of change as the RSPZ2 firmware will be updating the Kodiak and JPS bridge channel functionalities on all RSPZ2 interfaces. So keep an eye out for that update, and existing RSPZ2s in the field will be able to be updated with this new capability at no cost when available, as usual. And lastly, we can link a channel from the MCC console to one of the RSPZ2's digital backhaul interfaces. And as you can see, the RSPZ2 easily handles all 3 of these different disparate protocols without the need for a Z series controller. Socialization of the protocols is all taking place within that RSPZ2. There is no administrative involvement, for instance, with the push-to-talk over cellular services. So the console can be added or removed at any time without disturbing the push to talk over cellular services. And so here's what the configuration would look like from the RSPZ2's user interface perspective. This is a cross connection with a single backhaul configuration, and this is all user configured. And each of the digital backhauls should display a green link indicator, which we see here. Again, the ability to handle different protocols is really where the RSPZ2 shines and is able to easily integrate the MCC console channel into the push to talk over cellular talk group. And the important thing is we're not using a controller. So here's an example of a 4-channel MCC4 console. Right, so you see the MCC4 console on the right. It does have the ability to support 4 channels. It does have 4 PTT buttons. So each of the MCC channels in this example are associated to 4 different RSPZ2 dual channel gateways. Again, this is a controllerless architecture. So each RSPZ2 is provisioned independently with a cross connection with a single backhaul configuration. And so this is a logical diagram, hence the multiple lines connecting devices. So there are not 2 physical connections emerging from each of the RSPZ2s, nor are there 4 physical network interfaces emerging from the MCC4. So this is an image of the back of an RSPZ2. It does have a single network port, not 2. So really, we're just multiplexing the ports. So this. You can also see the 2 4-wire analog interfaces that would support the donor radios. And remember, in our last example, we are not using a donor radio on the port labeled radio 2, but instead this port is assigned to a push to talk over cellular service, and it is done digitally. Here's a physical network topology, which shows the actual network connections. The switch in this example will require Ethernet access to obviously allow connectivity to the push to talk over cellular services. Again, the beauty of the controller is its ability to handle many communication resources as well as all these different disparate digital protocols. So the MCC consoles are right at home in this very dynamic environment. Before a very simple MCC console integration with a push to talk over cellular service, the use of an RSPZ2 dual channel gateway is really perfect low cost controllerless solution. So another benefit is that for the most part, these protocols are self-healing. For example, if the network fails or a device is turned off and then restored, these digital links will self-establish their association over the network without user intervention. So that's very important. What are the drawbacks? Really, I can only think of a couple. You might think of a couple more yourselves. But because the MCC console channel is essentially nailed to the RSPZ2 digital interface, it cannot easily be moved to another push-to-talk over cellular talk group, for instance. So it is possible, but for instance, a technician will need to log into the RSPZ2 and log into the MCC console to reassign that link. It's not hard to do, but it cannot be done on the fly. But depending on your requirements, really, this might not be an issue for simple applications. Another drawback, because we can only establish peer-to-peer digital links, it's not easy to have multiple MCC consoles associated to the same push-to-talk over cellular channel. We will then need to incorporate a Z-series controller to broaden that digital socialization that I talked about when dealing with these multiple MCC consoles. So as the system expands and becomes more dynamic, those controllers then become more important. So again, because of this architecture is so flexible, you might not need a controller. So initially, you might not initially need that controller, but you can always add a controller down the road if flexibility or multiple resources need to be better managed. Your investment is always 100% viable. I hope this provides you with some good information regarding the very simple integration of an MCC console, the multi-channel console, with your preferred push-to-talk over cellular services, and without the cost or complexity of a system controller, which again you can add later down the road. And remember, whether you have a system that has a controller or does not need a controller, there are 0 recurring costs other than your usual push-to-talk over cellular monthly or annual subscription agreement that you have with your current service provider. You purchase a gateway, controller, or console, you own that equipment with no recurring costs. So I'd like to thank you all for joining the webcast today. And if you need more information regarding the push-to-talk over cellular services integrated with any of the JPS interoperability gateways or MCC Multi Channel Consoles, you can call us directly or you can visit our website at jpsinterop.com. So, Carol, do you have something you want to close with?
Thank you again so much for joining us today. We really appreciate it.
Everybody have a nice day. Appreciate it. Thank you, everybody, again.
Take care. Thank you.
All right. Thanks, Carol. Thanks, Jessica.